Wish everybody good afternoon and welcome to the 9th Sheffield IoT Meetup, our first daytime event that we're trialing out. So hopefully we shouldn't have too many glitches. I think hopefully we've ironed those out already prior to the start of this. My name is Mark Davies. I'm CEO of IoT. We're a cybersecurity specialist based here in Sheffield, dealing in IoT data security. I'll be hosting the next 90 minutes or so. We set up the IoT Meetup to build an IoT ecosystem that enables individuals, organizations, and interested parties to share their capabilities and hopefully stimulate conversations and some collaborations. We hope to bring together parties to enable real-world IoT applications to happen through facilitating technology, research and development, and commercial partnerships. And finally, to promote Sheffield as a leading IoT centre and to lay groundwork for larger events and network activities that reinforce its reputation, and hopefully a little bit more on a face-to-face basis rather than virtually next year. Now, I have to say this every event, it wouldn't be possible without our sponsors pitching of the University of Sheffield, who kindly take care of all the infrastructure for us. And as always, I'd like to thank Deborah, Fern and Kerry, the heroes who actually make this event happen. They'll be in the background as moderators, ensuring everything runs as smoothly as possible. And as I say, hopefully we've had all our technical issues ironed out just before the start of this. It's always great to see so many of you returning from our previous events and to welcome a lot of new online viewers as well, and some from abroad too. Today's theme is IoT thought leadership. The world of IoT is growing at a phenomenal rapid pace. Adoption of new technologies such as 5G, artificial intelligence is expected to drive the market growth in the coming years. The value of IoT in the customer experience is starting to be realized. However, there are still a long way between today's hype of smart Internet of Things and what is reality and what it will ultimately be. Now, whilst the landscape is constantly changing, it's hard to keep up with the latest news. We're inundated with new developments on a daily basis. So today, we're fortunate to have some great speakers who will share some of their thoughts as to what the future of IoT holds for us. We start off the session, and we're pleased to be joined today by Professor John Davis, who's the head of IoT research at British Telecom, or BT. That's showing my age. And he'll be talking about emerging technology and applications in IoT. We have John Pattinson, who's the commercial lead of IoT at Digital Catapult, talking about the challenges with the growth of IoT and the associated digital world is going to put a huge demand on human resources and the need to find people with the necessary skills. So he'll be talking about that. Frank McQuaid, Director of Capability at Block Digital, will be talking about digital twins and visualizing digital twins is the title of his speech. Pete Smith, who is the head of business development at IA Connects, will be looking at what the future of campuses in the higher educational establishment looks once this pandemic is over. And then finally, but not least, Tanya Suarez, who is the CEO of IoT Tribe and Blue Specs, and she'll be looking at IoT in the technological continuum. Now, if there are any questions throughout this webcast, I'd like to pose you'd like to pose to one of the speakers, please use the chat facility, and I'll pose them at the end of each section. At the end, I'm hoping if we've got enough time to have a short panel Q&A and also a 5-minute shout out to anybody wanting to promote any IoT activity, any event, any interest that you have. And finally, I'm sure we've all become accustomed to the technical glitches that occasionally occur on these live webcasts, so please bear with us should we encounter any. And so I'll hand you over now to our first speaker, Professor John Davis from BT.
Okay, thank you very much, Mark. Can you hear me?
Yes, John, I can hear you.
Can you hear me, Mark?
Yes. Yeah, John, I can hear you.
Okay.
Yeah, great.
Great. All right. So thanks, first of all, thanks very much for having me. And yeah, as Mark was saying, over the next 15 minutes or so, I'm going to talk about some of the future directions, some of the emerging technologies and applications for IoT. And I hope your slides are advancing.
Yes.
So the overview, great. The overview, I'll talk a little bit of history very briefly, how we got here and where we might be going next. In particular, then looking in a bit more detail at 3 of the key technologies influencing the direction of IoT, 5G networks, edge computing, and AI. And then I'm going to finish by talking about cyber physical systems, which in many ways I kind of think of as being the next generation of IoT, and talk briefly about one of BT's projects called Robot Highways in that cyber physical space. So yeah, I said a little bit of history. So the world's first stored program digital computer ran its first program in 1948 in Manchester. There had been other variants of computers earlier, but that was the first stored program digital computer. Why am I mentioning this? Well, essentially because if we look at the sorry, I'm trying to, there we go. Looking at the size of that computer, it's quite extraordinary when we step back and consider the miniaturization and the increase in computer power that has occurred in the years since 1948. So, you know, we now have tiny chips with many thousands times more power, more storage, much less usage of power, much lighter and smaller, and so on. And I mention this because I think this has been behind the drive and the increased phenomenon of IoT, which has been around as a concept since probably the mid-90s at least. But, you know, this miniaturization, falling costs, reduced power requirements, new networking capabilities, these are all driving sensors to be more efficient and cheaper and more feasible to be placed out there in the environment. And of course, sensors are everywhere in our environment, from industrial plants to goods to smart buildings to traffic to running shoes and even to cattle. So sensors are everywhere, and even connected cows. A Dutch startup called Spark has developed a connected cow system which measures things like the temperature of the cow and can detect when they may be unwell or pregnant. So they're out there. The number of sensors is increasing all the time, and I think this trend of miniaturization will probably continue to drive us forward in IoT. But I want to move on to talk, as I said, about 3 key technologies that are going to inform IoT going forward, and the first of those is 5G networking. 5G networking offers 3 key advances in the wireless networking arena. Massive machine type comms, MMTC, where we're envisaging things like 1 million different devices per square kilometre could be supported by the network. Ultra fast mobile broadband as well, the ability to deliver 10 gigabits per second, again over a wireless network. And finally, very low and very reliable, very low latency and very reliable comms, so a millisecond of latency in the best case. And that capability will drive IoT use cases which were previously or are currently very challenging in things like smart cities and precision agriculture and smart energy. If we take smart energy as an example, if we have millions of smart meters out there, and we have prosumers in the network who are providing energy as well as consuming energy, a very rich ecosystem, much richer than today's more sort of pipeline energy production and consumption process, then latency becomes key, because we need to be able to perform phase balancing in those electrical networks with potentially many hundreds or thousands of players. So that's just one example where low latency really starts to offer IoT use cases which weren't previously possible. And yeah, I'm sorry, I'm a slide behind, forgive me for that. So smart cities, precision agriculture and smart energy, examples of use cases which 5G can help to make more feasible. Another example is intelligent assisted living, and there are various aspects to this. So if we look bottom right there, continuous health monitoring is something that's gaining more and more interest. If you think about home consultations with doctors or specialists rather than going to a physical location like a GP surgery or a hospital. That's going to require a lot of bandwidth as more and more people do it. Similarly, individuals wearing many different types of biosensor and health sensor monitors to provide key information. Again, that speaks to this requirement for MMTC, the ability to have a very high density number of sensors active in a relatively small area. If we think about intelligent assisted driving, similarly, we'll need very low latency so that vehicles can react quickly to things that happen on the road if we're going to let them drive themselves. And similarly, top left there, what are sometimes referred to now as taptic kind of applications, essentially where you're navigating around an environment and you're getting interaction back from that environment. And if you think about a firefighter using those kind of apps in a smoke-filled environment, absolutely key that they get very quick feedback on where they're going and what they're doing. So some of the, just to give you a flavour of some of the IoT use cases that 5G networking will make possible. If we move on now to edge computing, which was my second kind of key technology driver, which is going to make possible new IoT applications. Computing, some of you may well know, but it's essentially about reducing the transmission of large amounts of data across the network, essentially by doing computation at the edge of the network and then sending a smaller amount of data. And a simple example shown on the screen here is video analytics of vehicles. It could be counting cars along a road to understand the vehicle density, or it could be counting spaces in a car park, or whatever. But the key point is you do that video analytics of the vehicles at the edge of the network, and then the only thing you send over the network is the car count or the number of free parking spaces or whatever it may be. You're just sending an integer across the network rather than a very voluminous video stream, for example. And that's one example of where edge computing can reduce strain on networks. So what are the advantages of the edge computing approach? Well, one is security and privacy. If we think about our traffic example, what we can do there is simply count the cars and throw away the video. So we have no record, for example, of the number plates of the cars, or we have no images of the drivers of the cars. We've actually thrown all of that away. We don't keep any of that data in the cloud. We only store the data that we wanted to extract. Network capacity and latency, I've already covered that, of course. You get a faster response and you don't send large volumes of data over the network. And then service critical apps, we're back to this issue of latency again and the ability to react very quickly. We can put some of our processing, not all probably, but some at the edge. And again, it's another way of addressing this latency issue. So I wanted to come back to the energy sector example I mentioned earlier. And this trend that I mentioned of increasing digitization and prosumerization, that's a horrible word, isn't it? But it basically means organizations or even individuals who both consume and produce electricity. So everything from somebody with solar panels on their roof feeding a bit of electricity back into the network, right to a much larger organization, perhaps a local authority or a corporate, with quite a significant ability to generate electricity from renewable sources. And then they can feed that back into the network when they wish, or they can store it in batteries and use it when network energy is expensive. They can use their own energy and start to be really quite smart about the way they use that energy. So this slide just goes into a little bit more detail on that. Essentially, we're talking about advanced smart metering infrastructure where people can feed in and consume energy, local energy exchanges. And one of the benefits of this, apart from reduced energy costs is improve resilience. Of course, if you've got energy much closer to the point of consumption, then you may have some protection from blackouts. And the edge requirement here is, the ability to perform phaser management on the network, because you need very up-to-date data reporting and control. And you've got many devices at the edge of the network, smart meters and so forth, contributing to a decentralized decision-making approach. So the desirability of edge processing, I think, is fairly clear there. So that's just one example of where edge processing, again, is going to make possible IoT type applications, which perhaps were previously more difficult. So the third technical area after edge computing is artificial intelligence, and probably people are aware that recently AI has made some really significant advances, things like Watson winning the general knowledge quiz against human contestants, the Go computer beating the world champion and discovering new strategies, better diagnoses and specialists in some medical areas, and so on and so forth. And it's certainly something that's very much in the news, has been in the news in the last few years. A particular subset of AI that's really been driving many of the recent advances is machine learning, and a particular approach to machine learning called deep learning, that enables computers to learn models or learn ways of reasoning, if you like, from very, very large training sets of data. And in the medical example, the training data would be tens of thousands, if not millions indeed, of previous cases with, for example, symptoms, treatment and outcomes, and then you start to learn what the best way to treat a patient is who present with a particular set of symptoms and so forth. And this can really work well, and it can sometimes work not so well. So this slide is simply by way of both showing how well it can work and showing perhaps a word of caution. So if you look at the leftmost column here, we can see some sentences extracted by an AI, an artificial intelligence, by looking at the image presented to it. So if you look top left, a person riding a motorcycle on a dirt road, that is a pretty smart interpretation of that image, and I think that's quite impressive. But then if we look right over to the right-hand side, we can see examples which aren't quite so impressive. So top right there, a dog is jumping to catch a frisbee. Well, there is a dog in the image, but there's no frisbee. And then if you go down one, you can see a refrigerator filled with lots of food and drink. Well, that's going to fool an automatically driven vehicle pretty quickly, isn't it, since there's a road sign covered with stickers. So there are lots of very powerful examples of where AI is working very well, but it's not there for every example in every application area right now. So I guess with IoT, we're talking about generating vast amounts of data through all these sensors, and the IoT technology gives us the capability to gather that data from the environment, transmit it over new network capabilities, and then to store and aggregate it in big data type technology. And then what AI gives us the ability to do is to extract intelligence, if you like, from that capability, from all that data. And here's a simple example of something that we did in AI. This is a traffic junction in Manchester, where we're using fixed traffic light phasing versus AI generated traffic light phasing, using sensors at the junction to understand how many cars there are and to determine what should go on. And I don't want to go into detail on this, but essentially that difference number you can see there, 2 hours 15 minutes, is the aggregated time saved by a whole set of vehicles across a 6-hour period at that junction. So the AI-based traffic light phasing is saving significant traffic time waiting at that particular junction. So to finish off, I wanted to talk a little bit about cyber physical systems, where kind of all these three technologies meet. And the Robot Highways project that we're doing at BT, it's collaborative with a number of partners, where we're trying to deploy robots on a farm to support the whole farming process, essentially. And let's go to the next slide. So this is the robot we'll be using from an SME called Saga Robotics, and we'll be deploying 7 of these robots at a fruit farm in Kent ultimately, and we will be addressing problems in the in the soft fruit sector. We will have robots doing a number of different use cases, such as fruit detection and forecasting when fruit is going to be ripe, fruit picking, moving that fruit to what they call the pack house, where it's picked up by trucks and taken to supermarkets or wherever, disease control, crop spraying, and so on. What's more, the robots will also automatically recharge themselves from renewable energy sources located on the farm, and therefore, you know, there's a whole fleet operations logistics considerations as well, to make sure that all the robots are recharged when they need to be, that we manage collision control and so forth. And this is just an example of a fruit picking appendix on a robot. And just to give you a flavor, we'll be using what we call a cloud edge architecture. So some things will be computed at the edge, right down on the robot. Some at the, so that's what we call the far edge. Some at the near edge, so on the farm itself, and then some in the cloud, according to the use case, the volumes of data that we need to process, and so on. So that was kind of a little glimpse of the future, if you like. Cyber physical systems, you know, increasing amounts of robotics and automated decision making coming into the process, whereas today's IoT applications mainly, not wholly, but mainly deliver information for analysis to provide insight. In CPS, we're going to the next phase where the software is using actuators to actually act on the physical world itself with a higher degree of autonomy than typically we might see today. And you know, the farm robot systems are an example of that. So that is a brief tour around how I see the technologies emerging and impacting on IoT in the future. And Mark, over to you. I don't know if you've got any time for Q&A.
That's great. Yeah, if we could just maybe take a couple of questions, John, if you wouldn't mind, just in case you can't make your way back later on in the session. One of the questions from Richard asking, we don't see BT as a data applications business delivering IoT solutions to the market today. So what role does BT see themselves playing in the growth of IoT in the UK? Is it primarily as a network and comms provider?
That's a great question. And the short answer is no. So for sure, we are, you know, a comms provider, and we would consider ourselves best in class in that arena, as you would expect. But we are definitely very interested in also operating at the data layer, if you will. Now, what that probably means is acting as an information broker, where we can offer a data platform which enables people to provide data onto the platform, and also enables data consumers to consume that data, kind of like a one-stop shop, if you will, where we take away the pain of getting hold of the data that an app developer might need for their particular application. And we see that as potentially offering economies of scale and lowering the barrier for participation for some people to get hold of the data that they need for their particular applications. And I think those kind of platforms are particularly applicable in environments where you've got multiple data providers, such as a smart city environment or a port environment. We've recently deployed a data platform in a port where you've got multiple stakeholders, you know, the port authority itself, you've got customers and excise, you've got ships coming into the port, you've got trucks leaving the port, you've got the local authority worried about traffic, and so on and so forth. So you have multiple players in the ecosystem, and that's where it gets really valuable to bring together IoT data from multiple organizations. So short answer, yes, we do connectivity and networks, of course, but we also want to provide data platforms.
And then I guess not really your area, because but I'm sure you have thoughts on it. So will the things like data rates, latency, connectivity be guaranteed as a service provider? Because they're quite important in such things as remote control, as an example, and also about pricing. So, with large volumes of data that be transferred across the network, understandably, edge computing will take a lot of that volume away. But when you're connecting up things for maybe years on end, how would somebody connecting their stuff up to the network be able to sort of project forward their costs on something like that?
Yeah, I mean, great question. So with the latency thing, and the need to guarantee that, I think it's early days, it's fair to say, in the 5G arena. Obviously, the 5G hasn't been around that long. But one thing we're starting to see emerge is the use of what we call private 5G networks. And of course, if a network is private, then it becomes a lot easier to guarantee latency and those kind of network characteristics. And the other interesting key thing about 5G is the ability to do what we call network slicing, so that over a public 5G network, you can kind of slice it up and offer bits of it, if you will, to particular customers, which again should help to guarantee the latency. And I think the second part of the question was around data volumes.
Yeah.
I guess, well, first of all, 5G is offering potentially 10 gig per second over a wireless network for millions of devices per kilometer. So that seems, quite a step up in terms of kind of data rates that can be supported, I guess. But, it's a never-ending problem, isn't it, in a sense? And no doubt people are already talking about 6G, and there will be future networks that will continue to increase that amount of bandwidth that's available.
Yeah, I read my first article on 6G the other day. So yeah, we've not even got 5G and we're talking about 6G already. Just one final question, John, and I know, as I say, you're on a tight deadline, so I appreciate that. But one from Joshua then, with all the examples of IoT being used in smart cities, in factories, in agri, how will IoT be used for telecom providers such as BT? Do you have any uses in IoT such as automated strength testing and maintenance of infrastructure?
Yes, excellent question. I mean, we're seeing various own use, as we call them, own use cases for BT. One thing we've done, for example, is we've put temperature and humidity detectors in a lot of our exchanges, and by detecting, adverse temperatures or humidity levels, we can we can reduce the amount of manual inspection and checks that need to be done, and B, we can anticipate better potential equipment failure and start to do predictive maintenance. And then another area, for example, is we've started to look at drones with one of our partners, in fact, to look at networks, to inspect networks and to understand whether there are problems with networks technically, but also intrusion detection, of course. If someone's climbing up a telegraph pole, you want to know about it. But the interesting thing about that is it goes for power networks as well, of course, and energy networks. So there's just a couple of quick examples where we're definitely very interested in what IoT can do for the telecom industry as well as what it can do for our customers.
Yeah, that's great. John, thank you so much for that. I appreciate, as I say, you're on a time schedule. Hopefully you'll be able to rejoin us at the back end of the session.
Yeah, I will rejoin if I can. And thanks to everybody for the questions, and thanks for your attention this afternoon.
Thanks very much, John. Cheers now.
Cheers, bye.
Bye-bye. We're running a little bit behind. Sorry, John Pattinson, for holding you up there a little bit. If I may introduce you, so John Pattinson, commercial lead, product lead for IoT at Digital Catapult. Title is Overcoming the Digital Skills Gap. So I'll go straight over to you, John. Thank you.
Okay, thank you, Mark, and hello to everyone. Good afternoon. So today, as Mark mentioned, I'm going to talk to you a little bit about the skills gap in digital in general in the UK, the challenges that industry are facing at the moment with attracting digital talent, and ultimately the challenge of applying digital technologies and making real business transformation happen within companies, and what Digital Catapult are doing to be able to help there. All right, so to start off with, just a quick introduction of Digital Catapult as an organisation. So we're the UK's leading advanced digital technology innovation centre, and we're here to support the early adoption of advanced technologies across the manufacturing and also the creative sectors. We're a non-profit, and we sit in a unique position, bridging the gap between academia and research, government, but also corporates and industry, and the innovators, the startups and the scale-up community, and acting almost as an interface between all of these different institutions to be able to accelerate the adoption of digital technologies. And one of the areas particularly that we focus heavily on is in helping startups and scale-ups to be able to make contact with corporates and industry, and helping industry to be able to work with these startups and to be able to frame the challenges that they face in a way that we can send challenges out to the innovator ecosystem and get them to be able to address those challenges and to be able to work together as companies. So we cover 4 different key technology areas. So the first one being future networks and IoT, which I'm focusing on particularly today. But also within future networks, we work in 5G and also low-powered wide area networks as well. Artificial intelligence and machine learning is another key area for us, as well as distributed systems, looking at blockchain, smart contracts, distributed ledgers, and then immersive as well, so AR, VR technologies, and considering how cross-technology use cases get brought together, as much as focusing on specific use cases within these different technology areas. So to focus on IoT, so what we see is that there's a real understanding of the importance of IoT within the manufacturing industries in the UK. There's an understanding of Industry 4.0 and that this is an important evolution in technology, and that the potential business benefits of such technologies. But we see that there's a challenge on one side around building the business case and understanding the value that these technologies can really add in practical terms to a business. But then on also moving from the pilot and the POC phase to scale. So a lot of companies have been able to prove the value of IoT on a small scale, get people interested and excited about the technologies, get the appetite for scaling the technologies, but it's a real challenge to be able to move to the full-scale rollout and ultimately to realize the return of investment of these technologies. And we see a key reason for this. There are multiple different reasons, of course, but one of the key reasons is digital skills. So getting the people on board that can really understand these technologies, can translate into business terms what the value is that can be realized from these particular technologies. And this is backed up by a survey from Make UK called the Innovation Monitor Report, and that looked at the key barriers to adoption of industrial digital technologies. and their survey was run in 2018, and digital skills was top of the list, and run again in 2020, and digital skills was still the #1 barrier to adoption of digital technologies in the industrial setting. Also, in a report by Deloitte, which looked at the intersection of readiness and responsibility in the terms of Industry 4.0, this showed that the majority of senior level CXOs were looking at instilling a culture of lifelong learning and within their organizations, and that training was a real top priority. Investment in training was a top priority from them. So there's a clear realization that something needs to be done in industry, that we need to invest in training and enabling these skills. But there's sometimes a challenge of actually realizing what skills are really needed and how to build up and to structure these programs to be able to actually increase the people's skill within the area of IoT, for example, and how that relates to their business, and pulling this into a sort of a comprehensive program. And that's really what we're aiming to do here with the IoT Discovery Program. Oh, these slides seem to be moving by themselves. So that's what we're aiming to address with the IoT Discovery Program. So the IoT Discovery Program is all about helping companies to understand the benefits of IoT to them, particularly as an organization. So not so much the generic benefits, but understanding for their particular business, how can these technologies be adopted? How can the business case be developed to be able to get the investment? And then ultimately, how can the correct technologies be selected that actually realize the benefits in the end and allow these use cases to be able to scale? And we do this by running bespoke workshops that are targeted at the particular industries that are involved, in facilitating conversations as much between the different companies that are involved and sharing ideas and different use cases and approach to IoT, as much of that approach as it is on getting the companies in touch with our own internal experts, informing them about different technology trends, how these trends can be realized within particular use cases, and understanding how the business case is formed and ultimately how the solutions are then implemented. So in the end, it's about helping companies to be able to understand the IoT landscape and to be the first to know about new technology developments that are particularly relevant to their business and to the industry that they're within. And also to enable industrial adopters to build a robust business case and a clear roadmap to the return of investment of the use case. So thinking beyond the initial POC, ultimately to scale, and when they can expect to see the return from the effort that they're putting into the use cases. So the program is run over 3 months. We design industry-specific technical masterclass sessions. Here we run various different workshops. We look at the strategic objectives of the companies that are involved on a one-to-one basis. We understand the challenges that companies are currently facing in achieving these strategic objectives. And then we start to develop solution ideas and come up with different business cases for the investment in these particular solutions. And by clearly understanding the strategic objectives and the particular challenges that the company is facing, then we identify specific use cases that really make sense to start first and most urgently. From there, we start to look at breaking down the business case. We look also at the various different technologies that are available, whether that be off the shelf, configured or customized for their particular business. So ultimately, at the end of this 3-month program, companies have the skills to be able to more effectively adopt IoT technologies. develop the robust business case, and understand the roadmap that gets them from that initial concept through to the full scaling of the particular use case. And just finally, so the types of industries that we're targeting with this program across 5 key areas: automotive and defense and aerospace, the built environment, energy and utilities companies, food and drink, and also foundation industries. So we have certain activities on the program where we have all companies together, and there's opportunities to exchange ideas, and then we have more specifically focused workshops that are targeted at single industries or even on a one-to-one basis with the companies. All right, so that's all of my slides for today.
That's great. Thank you so much, John. Very interesting. We were fortunate to have visited the Digital Catapult IoT labs in Houston at your offices there at the beginning of the year. And it's a great place. Pat Malloy did a great presentation and all the kit that was there for the attendees here. It's basically a lab full of IoT innovation. From small startups right through to big industries, with a variety of great IoT products in there. If you get an opportunity, I think Pat's trying to do a virtual tour of them on a regular basis. So if you do get a chance to go view it, please do. Just one thing, John, these workshops that you're running, how does anybody who would be interested in getting onto one of those, how do they go about it? When's the next one starting? Is it bespoke per customer, or is it sort of like a cohort? How does that work?
Yeah, so we're looking at starting another cohort of companies early next year, end of January, early February sort of time scale. And there we look at multiple different companies that are going through the program together. But we have sessions that are tailored either as the group as one, or as particular industries together, or single workshops for one company at a time. So it's really a mix between those different activities. So to be able to share ideas between the different companies, but at the same time really focus in on the particular needs of a single company and look at use cases that could really help their business.
For sure. And you know, this digital gap is going to be an increasing problem for us. So what support from the schools and colleges and unis should they be focusing on in sort of building a pipeline of digital skills for the future? How do you see that happening?
I mean, one of the key challenges that we see is that we have an older generation within industry that have got huge experience and are moving towards retirement, sometimes referred to as the silver tsunami as a trend. And the younger generations are tending not to be as interested in going particularly into these more industrial focused jobs. So I think really key is to try to build the sort of the understanding that there are exciting roles to be taken within an industry. There are apprenticeships programs, there are graduate programs that allow funding from industry for students to be able to be involved in courses that actually benefit that particular industry. And there are also programs that allow students to be able to go within those industries and actually realize that it is pretty exciting. And Industry 4.0 involves a lot of really impressive technologies that you know, the latest digital technologies and trends are very much relevant in this setting. And I think one thing that's really important to highlight is that, you know, within industry, if you're in a role as a digital engineer, you get to try out digital technologies on the shop floor, you get to really change processes and really influence the whole production flow through these different innovative technologies in a very sort of instant way. You know, you get to do iterative improvements and really see the outcome of the work that you're doing in this area. So it's an exciting space, but young people need to really realize this. So anything that can do to help that.
Absolutely agree with you, John. And sort of how do we encourage executives now who are in powers or positions of decision making? How do we convince them that it's a great idea to be involved in this and start thinking about digital transformation of their businesses? How do we frame that to get them enrolling in your program?
I think one of the interesting things that we see certainly since the current pandemic and COVID-19 that we have at the moment is there's been this realization that remote working has now become somewhat of a new normal, at least temporarily for us. And how easily companies have been able to transition to remote working and having their people working at home is just a testament for how powerful digital technologies are in general. And I think that could also be translated to how companies are run in a more digital form, as far as we see remote monitoring and optimization is a huge benefit. And it's easier now, I think, for a lot of people who have gone through this transition in the last 6 months and realized how things can be done more remotely and digitally, how this can actually be applied to wider within the business. So that's a key area. So remote monitoring and optimization, where there's huge potential, but then also on relying less on single engineers being in a physical sense within a particular location, and how we can share the knowledge of people across multiple different sites in a remote fashion. We can allow the data from multiple sites to be collected and optimized on a higher level, and there's more of this realization now we see from the current changes that we're going to.
Sure. Final question then for you, John. I have multiple ones there, so maybe you could respond to them on the chat facility. But final one then. So, big cost of this is instrumentation. How are we going to get past that barrier, as it were? Are there financial incentives that we can introduce? How can we get past that cost?
So just clarify what you mean by instrumentation.
Roy, would you like to just clarify that?
Mark, he can only add text in the chat. He'd need.
Yeah, here we go. My question is based on industry experience when working for HP. Think of a factor in the cost of putting reliable sensors, etc. in.
Okay, so I mean, the most important thing that we see is that there needs to be a clear business case and a clear path to realizing investment of a particular use case. The technology can be expensive. It can also be relatively low cost, but relative to the investment that's realized. So the most key thing that we see is rooting the business case within the innovation process. So that's number one. The other thing is around looking at what technology solutions are already available. Are they for your particular industry or maybe similar applications? And that means that you can dramatically lower the cost, and also you can work with solutions that are already industrial grade and really fulfill the purpose that they're intended for. And then also the other thing is around really keeping it simple in the beginning. So focusing on the minimal technology that's needed in the first case to be able to prove the business case, get people interested and excited about that particular use case, but also have your view on how to scale this particular use case. So technologies that are then needed once the use case is proven to be able to really scale this. So start small, prove it, and then expand out and scale from there.
That's great. Thank you, John. There's been quite a few questions. You might like to just respond in the chat message for us. But once again, thanks for a great presentation. Much appreciated.
Okay, thank you, Mark.
Thank you, John. Cheers. We're running a little bit behind, so I'm going to try and make up some time without. I won't do too much of a link. So really, just introduce you to Frank McQuaid. He's the director of capability at Brock Capital, and he'll be talking about visualizing digital twins. So hand you straight over to Frank.
Thank you very much, Mark. Thank you. So yes, I'll try and make up some time for you, but essentially, advance the slides. Block Digital was founded in 2000. We grew out of the Rolls-Royce Learning and Development Centre. Essentially, we specialise in the processing and communication of digital information, whatever form that might take. So we deal with things like 3D modelling, reusable assets, animation, immersive development. All of these come together to communicate, to ensure that people can understand the information that's around them. That could be a training solution, that could be dashboards, etc., etc. As part of that, we deliver IoT solutions. I've got an example here. This is the Wisdom platform that we did for Nordson. Interestingly, we talked in the previous conversation about business cases. In this particular business case, it was dependent on shop floor, tracking consumable levels. Nordson manufactures spray guns for car factories. And so we were able to order and manage at a factory level one consolidated consumable order, which hadn't been done before, and that paid for everything else. You talk about establishing a business case quickly. We've delivered this to 35 sites. We're now pushing it out to 1,000 sites, COVID allowing, and there's been obviously the hiccup with that. But that's almost the traditional stuff, and some of, I hate to use the word, but kind of the boring stuff. What we also do is the more immersive solutions. And so I've got two examples here of immersive solutions. We do this as VR solutions, but we also do AR solutions, etc. Predominantly built on gaming technology. But what we have on the left-hand side is a rolling road where a user can go in there and they can operate a truck, they can see how the truck is performing on the rolling road, they can strip away the truck itself, look at the engine, look at the data, look at the specific information coming off of the sensors. On the right hand side, we've got, again, another training solution. This is for Rolls-Royce. It's really aimed at how to strip a gas turbine and prepare it for travel. Now, I've shown you two things. I've shown you the data side of things and the visualization thing. I think the key message here is that visualization engages people. It gets people into the business case. It gets them into the point where they will keep coming back to engage the system. And what we're really trying to do here is mix the two, and that's what I'm going to talk about over the next few slides. But firstly, the way that we do it, we build these solutions is we go to our customers and we talk to them about process, we talk to them about data, we talk to them about geometry. And what we do is we pull them all together into our digital framework. We call it Tool SDK. And what we do there is we bring them all together to develop these frameworks and business cases, and then we push the solution out onto Block Hub, and that goes into things like manufacturing, training, services, etc. You can imagine. The point of our research, I've jumped too far there, let me go back. The point of our research is actually to democratize that. I know it's a terrible word, but essentially what we're looking to do here is actually build applications that, we call it Digital Twin Builder, where customers themselves, users themselves can go in and they can capture the process, they can capture the data, and they can capture the geometries, push that into a digital twin builder, and then themselves push it up onto the cloud and then out and manage that in a near real-time environment where they can change their processes, they can alter the dynamics of the IoT system, they can do that all in real time to take advantage of the best understanding of what their knowledge is. But the first thing I'll talk about really is the geometry. So what we've got here, when we talk about building digital twins, the first thing that you've got to do is you've got to hang it off an object of some kind, and a digital object. And what we do is we can build these digital objects in many, many ways. And what we'll do, a modeler can do it. They can do it from a drawing. We can take the CAD information and we can transmit that into a real-time mesh. To give you just briefly the difference between a CAD digital model and a real-time mesh is a CAD is optimized for manufacture. It's perfect in terms of accuracy and completely describes everything that's needed to manufacture a component. What we have in a real-time mesh is everything that we need to optimize and display that model quickly. So that's a little bit more like a game object. So you can see things on quite complex things visualized on an iPad, but you couldn't visualize complex CAD models on an iPad. That's essentially what I'm saying. On that left-hand side image, you'll see the two green objects. The one on the right-hand side of that is the manually produced model of the split engine stand from the Rolls-Royce VR solution. It took around about 65 days to develop that from scratch. The one on the left is processed from the CAD model. It takes, it's about 98% accurate. It's visually perfect, and it's taking us less than a day to automate that. So the idea being now is you can essentially drag and drop your CAD packages into a process, and then that will start to actually become the basis of your digital twin. The image on the right-hand side is a digital twin builder itself, and what you're able to do as the machine learning solution that processes that CAD, what we actually start to do is process the CAD and identify what we've called points of interaction. The interaction is basically functionality. So we're processing, say, that electric motor there, and we're identifying things like this is the power supply, this is the shaft, this is the armature, this is all of the various things that how that particular model works. And what we're able to do then, going on to the next slide, is we're able to take that particular point of interaction. In this particular case, we've got the shaft, the spindle, and what we do is we connect that into our IoT system. It's almost like a crocodile clip, and then we say that particular shaft will behave in this particular way based on this particular data source. And it's a lovely animation there, but I'm afraid you'll have to take my word for it with the PDF. But essentially, in this particular case, the shaft and the cube will spin based on the data. And we're driving this in a simple case from a CSV file, but that can actually come from a real-time IoT system as well. What we can then do is we can expand that out. And what we've got here is an electrical lab. And again, this is actually something we're building with the University of Derby. And it's basically it's there to allow students to perform tutorials remotely. As we're in the COVID world at the moment, I'm pretty sure that we won't go back to the old ways of working. We'll start to see more people working remotely or people with difficulty in getting access to labs. But what we've got here is the digital twin. It's actually been driven by a LabVIEW simulator in this case. But our next step in that development is actually to drive it from real labs. So in fact, we could have physical motors running. We could have the difference between people being present and people being remote, and both having the same experience. However, finally, the next level of the experiment is actually we're now starting to do that from the real live data. This is something that we're doing with the University of Leicester, the space lab down there. The instrument that we're looking at here, that particular shape, is a spacecraft optical sensor. And what we're doing is we're simulating launch. And what we basically do, put it on a vibration table, a shaker table, and then we sensor up the instrument, and then we vibrate it to make sure that it will cope with that launch. We gather we do a little bit of edge computing here. We gather the sensor data, and what we do is then pre-process that into a mesh at the sensor side. And what we generate is a mesh of about 4 million nodes every 2 minutes. But rather than transmit that it's about 25, 26 megabytes of information, give or take, what we do is then, based on a predetermined viewpoint, we actually translate that into a texture. And that texture is the thing that we upload, and that texture then gets wrapped onto the base geometry. You see that in the middle picture there. And you talk about network load, that picture typically tops out about a megabyte in size. And what we've done there is we've taken that base mesh, we've applied the texture to it. Our current focus of our research is actually in deforming that base mesh to actually highlight where the object's changed based on the shaker table, but that's a currently ongoing piece of work. And then what we've done in this particular case is we've pushed that out to an iPad, and what that person is standing there with the iPad, and that for all intents and purposes, that object, based on, as I say, two-minute updates, that for all intents and purposes is the object sitting on that person's desk. So, final slide. We've talked about, so IoT, you get traditional stuff. So you get the dashboards, you get the information, the industrial information, all being driven there, and you're really starting to look at this idea of status at a glance, and then you can start to look at trends. You can look at how things are actually behaving. What we've got there in the middle is actually the object that we've discussed. It's how we've textured it, and you can start to paint sensor data on in different ways. But I will say that one of our long-term goals, and actually something that we are very interested in at the moment, is actually using IoT data. And what we're doing here is we're actually visualizing the degradation of a component based on information coming in. In this particular case, we're cheating a little bit because we give the system helpful hints by applying empirical data. But actually what we want to do is someone sitting at a help desk, whether it's Rolls-Royce or whether it's Jaguar Land Rover, whoever, can actually get a good feel for where, based on the sensor data, where the condition of a particular engine or object is going to be at any particular point in time. So, a quick canter through what we're doing in terms of research, lots of books there, but any questions, please feel free.
That's great. Thank you so much, Frank. Really interesting. Where do you see the future of digital twins going? What's sort of on the horizon for that technology?
I think that in some respects it's a simple one, in that digital twins will change from being virtual objects like we saw there, where there was you're using an iPad to view it. We'll get to when things like the Google glasses become pervasive, then Apple AR glasses become pervasive. I think the next step is that we'll actually use this data to augment people's reality, and it'll become much more pervasive as engineers and technicians go around an industry just pulling down data as they require based on the context of where they are.
And would we see it happening more away from industry? Could I see it on my desktop one day when I want to use digital twin technology for something fairly straightforward?
Absolutely. I think that's the case. We're driving forward towards is this internet of digital twins, actually, where the digital twins, it becomes pervasive in your environment. If you want to see the football rather than watching it on a television, you could potentially drive a digital twin down onto your desktop and actually, sorry, onto your desk itself and actually watch the game being played out. We gather the data, so I don't see the problem.
I think that's one for 6G, isn't it?
Yes, I would suggest so.
Let's see, it's a quick question here. May I know who is the targeting customer of the proposed digital twin? Product design, manufacturing, process engineering, manufacturing operations, including maintenance suppliers. So who's the sort of the target customer?
Unfortunately, I think the answer is yes, all of the above. And the reason that I say that, I don't say it flippantly, is that we talk about lean engineering and we talk about lean manufacturing, we talk about waste. To my mind, the largest waste we have is knowledge management, is the loss of knowledge between all of those elements that you describe. We see people forgetting what the design principles were. We see what's happening in service not feeding into the next product life cycle. To my mind, it's always been that what's in the boxes in a node diagram's fine. It's the lines between them that get you every time. And so I think that what we're looking at these is actually a glue that helps to bind those things together.
Great. That's fantastic. Thank you, Frank. Thanks for sharing that with us today. Any further questions, put them on the chat, and I'm sure Frank wouldn't mind just answering there.
No problem. Thank you.
Brilliant. Thank you, sir. Straight over then to Pete Smith. He's head of business development at IA Connects. I'm hoping it hasn't. Yeah, there we go, Pete. I'll hand you straight over to you. I'm just trying to make up for lost time. Thanks for keeping.
No
thanks
problem.
for waiting. Cheers.
No problem. I'll try and keep it as brief as I can. I've only got 9 slides, so I'll try and get it in under 15 minutes for you. So just a quick introduction to myself. Pete Smith, Head of Business Development at iConnect Technology Limited. As a general description, we're an IoT solutions provider in many different areas, but today I'm going to speak to you about what will higher education campuses look like post COVID-19, and everything I'm going to speak about in the next few slides is pretty much solely based on the interactions we've had with universities in the UK and Ireland, a couple in Europe and some in North America as well. The general patterns we see, which are on the next slide, are kind of across all of those countries. It's not just the UK, I think, but I guess most people on the session today will be based in UK and Ireland. So there's been 6 kind of key elements that people have brought to us looking for potential solutions to help with that in higher education establishments. So generally just covering universities and some colleges in the UK, and then university level, which obviously in the US they call colleges as well. So these are the 6 things here which we are finding are the main drivers for change in higher education establishments during the COVID-19 pandemic. So adhering to the ever-changing government guidelines, earlier in November there was a huge change to the higher education guidelines, primarily based on the general country guidelines, but with some of the specific examples as well. Monitoring occupancy levels, either in buildings or across the whole of a campus, providing relevant cleaning and hygiene solutions, monitoring indoor air quality levels, and then some of the more practical things like looking at the online or working from home options. And what I would probably argue is the most important thing is the welfare of staff and students. I mean, IoT can play a huge part in some of those areas, but the 3 key ones that I see are listed here. So it's the monitoring the occupancy levels, the providing relevant cleaning and hygiene solutions, and monitoring indoor air quality levels. These are by no means the full extent of the things that IoT can have an impact on, but the 3 key ones that we've seen as a business in the last kind of 6 to 9 months. On the right there, you'll see the government's kind of staying COVID secure in 2020 steps. This should be in almost every office, higher education establishment, doctor surgery, wherever you may go, that's anywhere that's classed as a public building should have one of these risk assessment forms carried out and signed and dated. Obviously there's certain places that may need to have slightly stricter procedures in place, but I'll just be focusing on the higher education sector as we go through here. So the main one that we've seen, the main driver for higher education, particularly in the UK, has been occupancy monitoring, but to enable a range of different solutions for either the university facilities management team, the staff, the students, or a combination of all of the above. So occupancy monitoring to enable bookable desks, rooms and resources across campuses. During the COVID pandemic, this is useful to look at restricting the number of occupants in specific areas based on the current guidelines. So as the example you can see on the image here, a lot of the washroom or bathroom areas in universities will have an entrance and then kind of 5, 6 or more cubicles in each of those areas. But the universities are looking at having just a limited number of people in there. So if there's 6 cubicles as an example, they might only want 3 people going in there, because that's what their risk assessment has told them is a reasonable number to try and allow in there, looking at the social distancing guidelines as well. So trying to keep people a minimum of 1 metre apart, preferably 2. So depending on the size of the room, there may be a maximum number of people allowed in that particular area. Post-pandemic, in that scenario, it can be used for looking at cleaning schedules. If you know that after 100 people have gone into the toilets, then usually they need to be cleaned, then you can set that and bring that data back into either an FM system or BMS to utilize the data in another useful way post-pandemic. it's not just a solution that can be used for washrooms or bathroom areas. In the future, it could be used for looking at collecting attendance data for particular areas. It can look at whether libraries or other kind of open working areas are overcrowded, or there's more people trying to get in there than desks are available. There's lots of different ways that occupancy can be used to monitor things across campus, and can be of benefit to multiple people, not just the actual establishment itself. So, air quality monitoring. This is something that has kind of come to the forefront in the last few weeks for us, really, based on some research that has been done. I'll put a couple of links at the bottom of the slide here, which I believe will be shared after today's session, so that you can see where I've got the information from. So, air quality monitoring in general is something that companies in office blocks have been doing over the past kind of 2 to 3 years, as far as we're aware. It's really taken a giant leap forward with the higher education sector that we work with since the pandemic hit. There's been some belief prior to some of the more recent research that the better the air quality, the less likely that things like coronavirus will travel and spread between people in indoor settings. However, some of the more recent research now has a significant correlation to the CO2 levels to the transmission rate of COVID-19. I have to stress that this isn't kind of a definitive assumption. It's something that is a probable assumption based on the research that's been undertaken. But if the CO2 levels are higher, then there is a higher chance that coronavirus can be passed from person to person in an indoor setting. In other words, if there's less fresh air in the particular room where the CO2 is being monitored, then things can travel more easily from person to person. If there's more fresh air in the room and therefore a lower level of CO2, then things are less likely to travel. The other benefit of monitoring air quality, and particularly CO2 levels, is that it can have a huge impact on productivity, which is the second link I've put on the bottom of this slide. So if the CO2 levels go above roughly 1,000 parts per million, then the productivity levels start to decrease in that particular area. Now, this is something that was done as a research project for office spaces, but it's just as applicable to the higher education sector as well. So the number of people in a room will increase the levels of CO2, depending on the setup and the quality of the air conditioning system, or how often windows are open, will affect the levels of CO2 as well. But if you're finding that certain groups or classes in a university are doing worse than others in tests, for example, then it might be that there is some external factors at play as well, such as the CO2 levels. If someone's having to do an exam in a room that's got no windows, particularly old room, there's no aircon in there, and indoor air quality isn't particularly great, and those people are scoring significantly lower marks than people in a brand new room with air conditioning and options to open windows for extra ventilation, then it's something worth considering for higher education as well. If it can have a small impact on, the slide seems to have disappeared. I'll carry on this one until hopefully it comes back on.
Yeah, if you could do, if that's possible, Pete.
Yeah, no problem. So there we go, it's back now. Thank you. So yeah, if universities are looking to increase their exam results, then looking at something like air quality or the particular areas that exams are being taken in is something to consider in the future, as well as using it during COVID times. The third one, which we get asked a lot about, is whether we can do something to alert building managers when hand sanitizer stations need to be refilled or replaced. Now, it is classed under an IoT solution, because you can get systems which will send a notification by something like LoRaWAN to a device or to a particular person that can say, sanitizer station 3 is particularly low, please go and refill in the next 20 minutes so it doesn't run out. It's less of a what you might think of as a typical IoT solution, but it's something that during the pandemic is being asked for, and even post-pandemic, it's something that you could look at using for kind of key areas or cleaning facilities. If there's places that have cooking courses, childcare courses, anything with kind of physical education, then it might be something worth looking at in the future as well. I just thought I'd pop that one in there because it's something that we do get asked about a lot, and I believe that almost all places of work and higher education have a system in place for this now. It may be as manual as someone going around and checking if there is sanitizer left, or it may be that someone's using a more complex solution, which could potentially be an IoT one. So hopefully I'm running out of time here. I've got a couple of slides left. So what IoT solutions will enable the new normal? So everything that I've just spoken about, the occupancy monitoring, air quality, particularly CO2 levels, and hand sanitizer stations are just three of the potential solutions that could be used to get higher education back into a new level of normal. With the latest announcements around the vaccines, I'm hoping that this will be relatively soon, and potentially by the end of this education year, that things will be mostly back to normal anyway. But these solutions can help during COVID and post-COVID times, and there are multiple ways to do that, multiple benefits that people need to look at, and so, excuse me, and also depends on whether universities have kind of IoT plans in place already, which I know a lot do, or whether they're looking at building something out in the future. So on a more practical level and kind of personal level, the new normal is hopefully going to include reintroduction of lectures, seminars, practical sessions all on campus, environmental initiatives to improve air quality, not only reducing the risk of the transmission of COVID-19 and other diseases, but also increasing productivity levels and improved hygiene across the higher education population. I'm sure there's plenty of things that I could have added in here as well that I've not spoken about, but it'd be great to hear from anyone who has particular questions about solutions that they may find useful in higher education, and I'm happy to speak to them either straight after my session now or take it offline later on. So I think, Mark, I've just about run to time there.
Yeah, thanks so much. I'll just fire off one question with you, so I'm just sort of bring in Tanya. We're running about 10 minutes late, so but yeah, Pete, have you seen an increase in demand for these sort of solutions, particularly in this period, and then following on from the new normal into next year, hopefully? Do you see there being a major change in the way that we design our buildings, particularly in higher education, but in any new facilities that are coming in place where you've got masses of people utilising them? Do you see there being a big change in the design of those?
Yeah, so I'll answer your second question first.
Yeah.
So we see, particularly in the larger cities, that offices are looking to kind of reconfigure how they use those spaces. So nowadays, and well, pre-COVID, you would see the majority of areas being used for either specific desks or flexi desks for people going into the office to work. Whether they have meetings or anything in the office was kind of an irrelevant point. What we're seeing now and requests that we have are more for reconfiguring buildings, putting more meeting rooms in, putting more kind of flexible working areas in, so that people are coming into the office for a purpose rather than just to work. I think it's been proven quite well that most industries are capable of having their staff working from home, at least part-time. And I think that's something that's going to continue well into the future. I don't see everyone going back into the office as being kind of the new normal. I think it will be people going in for particular reasons, such as customer meetings. And then just quickly onto your first point, I think it was an increase in demand. Have you seen an increase in demand? Yeah. So in short, yes, particularly for the people counting type solutions. We've got into double figures of universities and colleges across the world using them now. And being totally honest, the one where it's been kind of most prevalent is in the toilets and bathroom areas. So somewhere that needs to be kept particularly clean because people are going to be touching lots of surfaces, the taps, the hand dryers, that kind of thing. And the most popular solutions tend to be where you can have some kind of smart display screen which has got an instruction on, such as enter or cleaning required, or is simply just showing a live count of people in that particular area. And a number of universities and colleges in the US have brought forward plans to install these solutions, which weren't kind of designed in for COVID. They were designing as a general improvement of the campus rather than a COVID solution. But it's they've brought them in early to eradicate the need for members of staff or external workers to physically count people in and out of that particular area. I could go on for a bit longer, but I know you're trying to get on to the next next presenter. So if anyone does have any other questions, please put them into the chat, or I think I've left my email on this final slide. Feel free to drop me an email on there as well.
Great, thank you, Pete. Really appreciate it.
No problem. Thanks so much.
Cheers now. Bye-bye. And lastly, we're going to get on to Tanya's slide. Yes, for people waiting. I know you're on a tight timeline today as well. Tanya runs IoT Tribe. IoTech participated in a little while back. Tanya is probably one of the biggest proponents and supporters of promoting IoT through the various programs and activities that you've portrayed. So I'll hand you straight over to Tanya and let us know what activity she's involved with right now. Thank you, Tanya.
Brilliant. Thank you very much, Mark. And it's a real pleasure to be with you here today. I've just really scrolling down the participants here. I can see very many well-known names: Nuke, Judy, obviously Mike Fultz, your colleague, and the one and only Tracy Johnson as well. So it's a real pleasure, as I say, to be able to be here, even if it's virtually and not with a glass of wine or beer over there in Sheffield. So we've heard from quite a few people this afternoon: John Davis, John Patterson, Frank and Peter, and they were all talking about solutions that can be applied in the here and now, things that are happening right now that you can take and integrate into your everyday business, into your everyday life. But what I wanted to do was to look at the future and how things might be evolving. So, whoops, oversensitive mouse there. There we go. So let's just look at some of the data that show or demonstrate how much things are changing and how rapidly they're changing. If we look at how many companies have suffered from digitally transformative events, in the last year alone, and that's excluding COVID, 82% have reported suffering from cybersecurity attacks or having some other disruptive events come into their business landscape and say, hey, you can't carry on like this. Secondly, build and buy. It used to be the case that companies would basically develop things in-house. They'd be looking at sticking sensors onto their machinery. They'd be looking at developing their own programs, their own software, because they thought that that was the best way to protect their IP and to protect their businesses. And while there may be a certain degree of that, the fact is that even companies like IBM are recognizing that they can't attract all the talent in the world, that they do actually have to collaborate with others, not least to see how their technology can integrate and can become interoperable with other systems and other solutions. The third thing is connected by default. There are studies already underway that show that the companies that do invest heavily in digital transformation are likely to be market leaders. They are able to generate more revenue and more innovation, which of course will make them more resilient in the future. So what is it that contributes to the situation, and how is that situation going to evolve as we continue to move on into the future? Well, there are a number of things. First of all, we're seeing a trend and paradigm shift. Whereas most data processing now happens in the cloud, the proportions are likely to be inverted in the next 5 years. So whereas now it's 80% is in the cloud, 20% on the edge, those proportions, as I say, are going to be inverted in the near future. And that actually has implications for hardware and microelectronics. That means that the devices are once again going to be really important. That means devices and machinery that are actually within factories. It means the devices and supercomputers that you have in your pockets, in your handbags. All of these pieces of hardware are going to have to interact together. They're going to have to be much more secure. They're going to have to process a lot more data rather than just act as recipients of data and then transmit that up into a cloud. The other point is that the closer to the edge, the more specific applications need to be. And this is really going to be important for sectors such as healthcare, but also agriculture. We heard, I think it was from John Davis, about some of the solutions they have for fruit picking, where they had some robots there that were going to be acting on data and receiving data on whether fruit was mature enough, was ripe enough to be picked. That's just one application. If you look at healthcare, that's another area in which the devices are going to be collecting and analyzing data in real time so that the healthcare professionals can make the best decision possible at the moment that decision needs to be made. And all of this contributes to a new environment, which is now being known as the computing continuum. The mix of devices of different domains actually mean that whatever application is deployed, whatever technology is being used, it's probably going to have to deal with operating across different communications infrastructures, different domains, and probably also going to have to act on different data sets. To a certain degree, there's going to be a federation or a move towards federation of data sets at that device level, which is going to be very challenging for the authorities to police and to deal with adequately when there are breaches of that data, particularly when it's relating to private data. So, oops, sorry again, there we go. The other element that really will shake things up, and again, I think it's John Patterson that referred to this in relation to the skills that are necessary to deal with these new technologies that are not just going to have to be developed, but also deployed. If we look at, and my apologies to anyone who feels that they might fit within this, but if you look at the skills that the IT profession, and nobody calls it the IT profession anymore for a start really, if you look at all the skills that were required even a decade ago, they're probably quite obsolete. They're certainly not at the top of their game unless they've been engaging in continuously upskilling themselves and understanding what new technologies are being deployed and the language that's required to actually operate and interact with those technologies. The obsolescence cycle is very definitely getting shorter, and there are 1.8 million jobs just in the information technologies that are going to be unfulfilled by 2022. That's a study by IDC. This is we're actually fortunate enough to be the Secretariat for the European Commission's Digital Skills and Jobs Coalition, which involves organisations large and small from across Europe, including the UK, in coming together and pledging to reskill or upskill workers to get those digital skills out into society. And as part of that, we have a really privileged view of what is happening in the here and now, but also how that here and now is going to pan out into the future. And basically 2 out of 3 organisations are telling us that they're having problems in actually finding people that can come into their organisations and understand how AI can be deployed, and not just how it can be deployed, but how it can integrate with legacy technology, what the problems they might be facing in the future few years down the line are with certain deployments of AI. So it's really something that if there are no skills, then nothing else matters. The technology can exist, but if you don't have the ability to understand the implication for your company, both in the good and the positive and in the negative, then that's not going to be a great situation to be in. And again, 45% cite the lack of skills amongst existing staff. I think that will not come to as a surprise to any of us on this call today. More importantly, or more worryingly, not more importantly, but perhaps more worryingly, if we look at the amount of money that's being ploughed into education, funding a PhD is not a cheap exercise. It is something that requires, in addition to the monetary investment of the person actually performing or studying for the PhD themselves, there's a whole institution around that that's built up, a whole body of knowledge that goes into that PhD, and essentially we are putting a lot of money into this, but then we're not providing an environment in which those AI PhDs can really find fulfilling careers in Europe. 15% go to the US, but actually if you just do a little bit of maths there, most of the rest go to China. And once again, that's probably something that everyone kind of knows, but it's actually going to be a big problem for us in the future. So with all of this, really the question is, what part of the problem or the future do you want us to focus on? In terms of geopolitics, there are questions now regarding what you do with your markets. Do you open up your markets so that they're free to competition and best in class? Or do you actually support national champions with everything that comes with that? Talent. Looking at talent, talent actually requires data. AI talent, very specifically, requires data to be trained and to turn that raw data into productive services or products that can be used by society and by businesses. And I think that the important thing there is relating to collective explainability. If you are developing or integrating or adopting AI, you just don't need a developer or a vendor to come in. You're going to need trainers, explainers, and sustainers of that AI. I think this is my final slide, and I'll cede the floor to questions and to interesting conversations that I'm sure will arise from the previous presentations. But what does all this mean for you? Well, first of all, more collaboration. By collaborating, and I think here initiatives such as the IoT Meetup Sheffield, which has been really driven by Mark and the team at Sheffield University, I think, as well, and Kerry. I think initiatives like that are really essential for making sure that everything that evolves from a technological perspective can evolve in a way that makes sense to society and to businesses across the globe, regardless of where they might be. That collaboration means that we're going to be able to understand interaction and integration, both in vertical terms, but also in horizontal terms. What do I mean by horizontal terms? Well, across different domains. Are there applications that can be used not just in smart buildings, but also to save energy, for example, in agriculture? The second point here, open source as a standard. There are increasingly initiatives that are proposing that the public sector, very specifically, embraces open source as a way to avoid or minimize at least vendor lock-in. That means that new companies, new players can always come in. It means that data sets and actions are traceable. There are some arguments, although the jury, I think, is out on this in the sense that open source is considered by some to be more secure than proprietary technology. So there are a whole host of things there that will have to come into the conversation moving forward. And my final point here is, of course, and we've known this for a while, again, Mark and Mike will attest to this. This is something that IoT Tribe has been very, very insistent on from the beginning: secure and compliant by design. Anything that's developed has to be from the start something, whether it's at infrastructure level, a firmware, data level, everything has to incorporate security and compliance at the very first moment. I think I shall leave it there. As I say, I'd be very happy for anyone to reach out and to continue the discussion. If I may, Mark, tomorrow we've got an event on cloud and skills for the cloud, but it's a much broader conversation about where the cloud policies in Europe need to go. So if I may, I'll post that in the chat. It's free, so if anyone has a particular interest in that, they can join up as well.
That's great. Thank you so much, Tanya. Brilliant presentation, a real eye-opener as to the problems and challenges that we face. To back up John's earlier thing about the digital skills gap that we face, as well as all the other things. Tell me, what's your thoughts on regulation and legislation? Is that going to support the adoption of IoT, inhibit it, delay it? What's your thoughts on that, particularly as you're quite involved with IoT in Europe?
Yeah, I think that's always one of the main questions. I think one of the key things is that regulation always has to follow the market. So first of all, you have to make sure there is a market, that there is adoption, and then you can really understand what needs to be enforced through regulation and through more legal mechanisms. Before regulations, there is a whole level of activities around standardization and normalization, which is the pre-regulatory phase, if you like, of IoT development and adoption. And I think that's the key. That's where everyone who wants to have their say should really be, joining that debate and, making their case.
Yeah, most certainly. As you quite rightly mentioned, that we're very, very keen on ensuring things like secure by design are baked into any kind of design of IoT. And you're a keen advocate for IoT Tribe up in Barnsley, which brings us on to sort of the north-south divide. You've got, you're supporting business in Yorkshire, in Barnsley and surrounding areas, and trying to attract talent into the region. What do you see as being a leg up, as it were, to sort of getting stuff out from London and south? And this is not a north-south bashing. It's just how do we level that up, to quote the current trend?
Well, actually, I would totally agree with you that things do need to be leveled up. And actually, I was recording a session for Switch, which is the big Singaporean tech event. It's got thousands of people. And one of my points, I was talking about UK market access and talking about UK tech generally. And Tracy, you'll be very pleased to hear this, but I specifically said, and tech in the UK does not mean London. Tech in the UK means London, Barnsley, it means Dundee, and it means Cardiff, and everywhere in between. And I think that one of the things that we need to do is to make sure that companies and talent from wherever it exists in the UK has the opportunity to showcase itself and to access international events that can really enable collaborations to take part, for people to be visible, for possible partnerships to be explored. And once again, my congratulations to you, because I think that that's one of the things that you do really well.
No, most certainly. Well, Tanya, thank you ever so much. I know, again, you're on quite a time constraint, so that you're actually sitting in also on another event today, and we were overrun. So I'm not sure we'll have the opportunity really to have the panel discussion I was hoping for, to sort of pick your brains a little bit more about the future. But I think you did it very well in your slide deck there. So can I just thank you very much for joining us today. And so I can wrap this up in the right time. So Robin, if I can hand over to you to highlight the activity KTN is doing in the security by design that Tanya mentioned earlier. Thank you, Tanya.
Thanks all.
Thank you, Tanya. Appreciate it.
Elizabeth, we just need to make Robin Kennedy a moderator. Thanks a lot.
Thank you. Can you hear me now?
Yes, we can. Thanks.
Fantastic.
Thanks,
Thank you. Would you be able to put the slide up that I sent you?
Is that it,
Yeah,
Robin?
Okay, I can see it now. Thank you very much. Thank you very much, Mark, for the opportunity to say a few words here. So I'm Robin Kennedy. I work for the KTN, or the Knowledge Transfer Network, as you may know. And this is about digital security by design. It's a program funded by Innovate UK's Industrial Strategy Challenge Fund. It aims to radically update the foundations of the UK's insecure digital computing infrastructure. And as Tanya mentioned, this is particularly relevant for perhaps this community, because if you're talking about IoT and secure hardware at the edge, this is a problem that is only going to grow. ARM are the leading industrial supporters on this, and it's based on work carried out at the University of Cambridge called CHERRY, which is Capability Hardware Enhanced Risk Instructions. And it's about protecting memory unsafe programming languages like C and C++ from widely exploited vulnerabilities like buffer overflow attacks. Now, there will be challenges in implementing this, and Innovate UK recognise that. And so this competition is about investigating those challenges in terms of adoption, the technology across the software development spectrum, requirements, dependencies, and other issues like that. So the headline is, there is a briefing event this Friday, the 27th at 11 o'clock. The best way to find it is to search for innovation funding service competitions. You should find it there. The link's on the screen, and I'm going to put that in the chat as well just now. The headlines are, it's only open to UK registered SMEs. These are fast projects, 6 months maximum. The funding is between 40 and 80k that can be claimed. Closing date's on the 13th of January. And there's £1.5 million in total up for grabs, and it's called de minimis, which in other words means it's 100% funded, which is unusual for Innovate competitions. Normally SMEs would have to contribute something, but in this case you can claim for something between 40 and 80k, and well, you can top it up yourself, you don't have to. So that's the headline story. I'll put my contact details in the chat, so if anyone wants to get in touch and ask me some more, but do have a look at it, do tell the briefing if you can. If not, the recording will be available at that link afterwards. I think that's all. Back to you, Mark.
Great, thank you very much, Robin. We've registered for that, so looking forward to listening to you on Friday. Okay, we're getting close to our now. I'll just do a quick shout out of activities that are going on. Forthcoming is the Smart Sheffield event. That's December the 7th. And the link is just there if you'd like to register for that event. Any other shout outs, please just pop it into the web chats there, and I'll happily advertise it for you now, and also follow up on our promotion. Just as a reminder, all of these slides will be available on the Pitching website over the course of the next few days once it's uploaded. We've also got Sheffield.digital, the various events that are going on over the forthcoming days. It's beginning to wind down before Christmas, but there's a fair amount of activity. Sheffield.digital advertising there again. The website, just go onto theirs. And IoT Tribe, just to promote their next intake, is going to be advertised in December, with the initial selection process occurring in the new year. Specialising in connected places, so go to iottribe.org to find out a little bit more information there. IoT Security Foundation starts at the beginning of the next month. It is a virtual conference this year, each day split into a particular topic. Pop into iotsfconference.com. it's a great conference. I sat into it in the real one last year, and a really informative conference, particularly if you're into security by design. And finally, just a huge thank you to the Pitch-In, who've sponsored these events all through the year. Thanks, as I say, to all the organisers and for allowing us to use blackboards during our meetups. They've just released their new newsletter, so go to their to the website again, as mentioned there. And then finally, it's just a huge thank you to all of you for attending our sessions over the last year. It got off to a great start, and then straight into the virtual ones. Thank you for standing by us. We're looking at how we can get into the hybrid situation at some point next year once the COVID crisis is over. We're looking at different ways that we can present and different events. So we look forward to welcome you in a much more informal style as far as beers and pizzas, etc. are concerned. So fingers crossed that will happen sooner rather than later. So yeah, a huge thank you to the Pitch-In and to all our supporters as well. And most importantly, thank you for taking the time out and coming and joining us today to listening to our meetup. So that wraps it up. I will hopefully see you in 2021. In the meantime, have a great unlocking next week, and have a great December, hopefully. Cheers now. Bye-bye.